So this video is for the purpose of Math 1012, session 1.10, and that's prime numbers and prime factorization. So essentially, prime numbers are just numbers that cannot be divided. So let me type this down. Prime numbers are numbers that cannot be divided evenly by any numbers other than one or itself. So for example, 7, right? 11, 23, 47. Right? Those are numbers that cannot be divided just itself, right? The opposite is numbers that can be divided by any whole numbers, outside of one and itself, are called composite numbers. Composite numbers like is composed of something. So for example, it will be 15 is a composite number because 15 is 3 times 5. So let me get the simpler times 5, right? Or 40, right? 40 is equal to 5 times 8. Right? That's two numbers that can be put together, multiplied together, and give you the whole number. So that's what we mean by composite numbers. So the question is, how do we know? How do we know if a number is a prime number? So for example, right? Say given the number, let's just find something a little bit bigger, like 97. Is it a prime number or a composite number? So the problem with 97 is a big number, right? So, and you don't want to be doing the calculation for the entire hour, just trying to find numbers that can go to 97. So here's what I do. Here's my rule. I would take out from session 1.9, which is the rule of this divisibility, and just go like this: 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? I'll stop at 10. That's for a reason. So you don't always stop at 10, but let's say, can 2 go to 97? Now, 97 is not even, is an odd number, right? So, no. Can 3 go to 97? So remember, the rule is 9 plus 7. 9 plus 7 is 16. Can 3 go to 16? No. So that's the trick, right? You don't have to use that trick. You can use a calculator. If 2 doesn't go in, 4 doesn't go in. 6 doesn't go in. 8 doesn't go in. 10 doesn't go in. Right? If 2 doesn't go in, all the bigger even numbers not going to have an opportunity to go to 97. Can 5 go to 97? No, because it doesn't end with 0 nor 5. 7, well, you can use calculator if you want to. Let me just use calculator. Right? So calculator. 97 divided by 5. Nope. I mean, it goes in, but not evenly, right? It's got decimal number, right? And we'll get into decimal number later. So, I mean, how do I cancel that? Right. So I don't really use this very often. So, no. If 3 doesn't go in, 9 is not going to go in. So, no. So you're like, well, when do I stop? Do I keep going to 11, 12? Well, here's the thing. Think about this, right? Every number you have listed here cannot go into 97. So the next number is 11. And since no number before 11 can go to 97, the best you can do is 11 times 11. So the best we have is 11 times 11. Right? Because think about it, right? Every other number cannot go in. So if any number can go 97, it would have to be 11 or above 11. But here's the thing. 11 times 11 is 121. That is larger than 97. So that means 97 must be our prime number. So that's the trick. Basically, you keep on looking for numbers that can go to 97. But when you get big enough, when it multiplies itself and it's bigger than that number, that is the end. You don't have to check anymore. It's a prime number. Right. I want to show you another example though. Another example is 91, a prime number. So this is a tricky one. 91. I'm gonna do the same thing as before. I just get all the number up here. Of course, I'm gonna delete the nodes. Now for 91, the question is, can you find any numbers at all that can go to 91? And of course, that's a no right here. 2 is a no. Can 3 go in? Well, 9 plus 1 is 10, and 3 cannot go into 10, so that's a no. If 2 cannot go in, 4 cannot go in, 6 cannot go in, 8 cannot go in, 10 cannot go in. Now, 5 is not going to go in, we know that. Now, 9 cannot go in because 3 cannot go in. But now it's 7. I know it's very tempting for people just to say it's a prime number at this point, but you have to check. Let's try. Calculator. 91 divided by 7. Enter. 13. Yes. So it turns out 91 equals 7 times 13. So indeed, 91 is not a prime number. It is a composite number. This one's tricky, so you must see it on the test and all that. Just special examples. 0 and 1 are neither prime number nor composite number. So they are special cases. 0 and 1 are just kind of on their own, right? So prime number, composite number, you really have to decide from 2 to above, but nothing before that. So that's just some definition with the math, that people come up with that, in the beginning. So if you ever see that on the test or the homework, just say it's neither. Same thing with negative or any other numbers you see. It has to be whole numbers, right? To be considered, you have to be a whole number that is larger than or equal to 2. 2, 3, 4, 5, and all the way up. So that is the end of prime numbers. So what is prime factorization? Prime factorization is a very useful tool to get things going when you have a big number. So, for example, it is a method to break down a large number. So now, let a large composite number. How about it? So here's an example. We want to find the prime factorization of, let's say, 200. So 200, we know that, and I'm going to switch over to the paint function that we have. So 200, let me say, sorry, I cannot draw. I'm using a mouse here, so that's a little bit tough. You know what? I forgot I can do this. I can do a text box. Let me see. What's a text box? Yep, that is. So 200. Right. So 200. So here's the deal. I can break this guy into two numbers because it's a composite number. So which two numbers is up to you. I would say 2 times 100. Okay. Because 2 times 100 is 200, right? So you know what? I will do one more. I'll go ahead and so 2, there's nothing to do about this guy, right? I'll break this guy up just like this. Now we'll go and say this is 2 again, right? And this 2 times 50. Now, some of you guys might say it's 10 times 10. That's okay. 4 times 25. That's okay. Doesn't matter. And since you're breaking it down, doesn't matter how you do it. So 50 is 2 times 25. And I'll do one more time. And this is going to be 5 and 5. So together, this is 2 times 2 times 2 times 5 times 5. And this is what 200 equals to. Like that. That's the answer. So this, on the right-hand side, is the prime factorization of that number on the left, 200. So let's do one more, just make sure. So here's another one. Let's just say we have something, a little bit bigger. Say 155, right? So same thing. I'll try to break it up. This time, you are always trying to look for the weakness. 155, answer 5, right? So that's all. That's what we look at. I was like, well, then 5 must be able to go in, right? So 5 goes in there. You can use calculator if you want to. It's going to be 31. And you're like, well, is there anything else we can do? Not really. 5 and 31, that's the best you can do. So this is the answer, 5 times 31. And that's it for prime factorization. And it's not too difficult. This would get you prepared when you do fractions. And that's the end of the session.